I am Francisco Orchard. I work at 𝘃𝗶𝗴𝗃, and as Laura said, I am the main developer of epitweetr. And I'm going to talk today about this tool, how it works, and some technical details about it. So first of all, let's talk about the primary objective of the tool, which is, as Laura said, to detect early signals and potential threats or events by topic and geographical unit. So we will define the topics, and we want to know where things are going on. And the second objective is to enable users through an interactive interface to explore this information. So we have some reports you will be able to use. And now, so principles about using epitweetr. First of all, is free as a speech. It's open source, available from CRAN, and GitHub too. Is powerful. You can collect until 1.5 billion tweets per year. It's a maximum, and uses machine learning to detect geographical mention on tweets. Something important too is that it runs locally. It runs on your laptop, and so after you download tweets, all processing is local. So no need for services or servers. You can run it on your laptop or in a server, but it's up to you to choose how to use it. It runs continuously, so it will collect, geolocate, and detect alerts and send emails when alerts are detected. And finally, it can also recover automatically from downtimes with certain limits. And it's customizable. You can easily add your own topics, so you can target whatever you're interested on. And you have an R API that allows you to create your own reports. So how this works. So basically, there are main three underlying processes that are working when you install epitweetr. One is the tweet collection that is running all the time. Then you have some processing going on. So we obtain the location information, what we call geolocalizing, from all the tweets. Then we are going to aggregate the data. So we need to count tweets to generate time series. And finally, we are doing some signal detection and sending emails when we found something that is not normal. And so that is the underlying processes. And then you have also a front end, which is an interactive Shiny application that allows you to see the data visualization and make some configurations on the tool. So the tweet collection is happening each 4 hours, but you can customize that number of times, how often you will receive the alerts, and you can change all that into the configuration tab. So, so in the Shiny app, you have the reports, as I said, and you also have the configuration tab. And in that configuration tab that we are going to see after this presentation, you can check the status of the background processes to see if everything is going on properly. You can modify the setup of the tool. So you can change the topics, your queries to your topics. You can change the languages you are using for collecting tweets. You can choose what are your important users. So for some specific accounts, we monitor the number of tweets for those accounts. So, and that can be important to detect if an alert is liable on. And we have also, you can change country and region definitions. And you can change general settings on tweet collection, signal detection, and alert generation. Okay, so I was talking about the configuration tab, and we also have, as I said, a dashboard with some reports. So the difference, you will find some difference between these two interfaces is that in the dashboard, you will perform exploratory analysis. So you can play with anything in that page without worrying about affecting anything. It's just exploratory, and everything is calculated on the fly. And then you have also but in the configuration tab, you will set up the background processes. So if you change something in the configuration page, it will affect how the alert detection process is performed. So How we collect tweets. So we use the Twitter standard search API, which is provided by Twitter. So it has some limitations. By example, it's only limited to the last 7 days. So we build history based on that. That is why a search needs to run continuously. It's not exhaustive. It's focused on relevance, and not all tweets are indexed. But it's still limited to 4 to 3 million tweets per day, which is more than enough, and it's free. So that's enough to meet the objectives of the tool. So we use that search API, and in order to collect tweets, we define topics. And so as you can see here, we have an Excel file where you can define your topics. So you can change them because, as you can know, like topics can change in time. So epitweetr allows you to modify the list of topics. Also, some tips that are important is that if you change anything here, it won't affect history. So you can open this Excel file, you can download it from the tool, and you can make the modifications you want to fit your needs. And if you add or you remove topics, it wouldn't affect historical data. Just starting from the moment you upload it again to the tool. Another thing important is topic is in the topic column is just an ID, and you should never change it because it's what allows you to connect new tweets with history. But you can use the column label to choose what is the name of the topic you will see in the application. And so you can download from the tool. You have a button in the configuration pane to download the current topics. You can change it, and then you can just upload it back again to apply those changes. So to add a topic, you just need to add a new line into this spreadsheet, and then you can define the topic ID, the label, and you have 3 columns. One that define what the topic is. The main one is the query. So this first one to okay. So the alpha and the outliers alpha are 2 columns that are related with the alert detection algorithm. So the alpha is the false positive rate of what we're going to consider as an alert. So the higher the alpha is, the more false positive rates you will get, and the lower you put it, you will be more sure that actually the alerts are actually alerts. And then also we're going to if in the history when we are going to detect alerts, we have some outliers, we are going to downweight them in order to avoid history previous alerts to hide current alerts. So this value here, outliers alpha for the topics, is also the false positive rate of historical points to be considered as an outlier. But we're going to discuss a little bit more of this in further slides. And then you have the query. And so the query are some keywords and operators that are defined by Twitter. And so you have, by example, if you just put, as is shown here, hemorrhagic fever separated with a space that is considered as an AND, it will match any tweet containing hemorrhagic or fever. But if you want to perform an exact match, then you can use double quotes. So to match exactly hemorrhagic fever together, as it's shown here. And also a best practice is to limit to 10 keywords an operator, because there is also a limit on the size of the query that is on next slide. So you can go over 10 keywords an operator, but Twitter could limit your query by complexity. So they suggest you to keep it as simple as possible, but you can still go a little bit over that. So you can try and see how it goes, your different queries. And And so you can have OR operator too. And if you add a minus, it will work. So minus music, minus metal will exclude tweets containing those words. And well, the maximum is 500 characters, as I already said. And so once you have done all your changes in this spreadsheet, you can just upload it again. And the tool will start collecting tweets using this new definition. And if you made a mistake, you can download the defaults and change it again and apply it again. Okay, so this query definition is going to tell the tool what tweets to collect, but how we actually collect them. The Twitter API allows us to perform a certain number of requests so there is a limit on the number of queries, and we need to try to evenly distribute them between all your topics. So what we do is that based on the search span you define on the tool, which can be like something like 4 hours, you can customize. We're going to define time windows, and a particular time X, we're going to go back 4 hours. And we're going to start collecting at time X. We're going to start collecting tweets from that moment until the 4 hours behind. So what this image trying to explain is that as time goes on, we start each line is trying to show a new request. So each request, as time is flowing during the current window, is trying to get older and older tweets from the previous window. So at a moment, we're going to, as time flows, we're going to start collecting older and older and older tweets until we're going to finish the 4 hour block. And at this moment, we have some free time. We're going to use to recover tweets from older periods that we might not have, we're able to finish, maybe because there were too many tweets or because we had some downtime. So here we use this time to recover, to get more tweets for previous period if necessary. And at the end of these 4 hour blocks, all these start again. And we do that for all your tweets in a round robin strategy. So that means that we're distributing requests evenly between all topics. Okay, so by using these principles, the tool got some tweets and stored those tweets locally in your machine. So now the next thing is to know which country or which place these topics are talking about. And so how we do that? So we have a process, we call it geolocation, that is parallel to tweet collection. And what we are doing is trying to find geographical information on the tweet. The main source is the tweet text. That means that we're going to see if in the tweet text or in the retweeted text, if there is a retweet, there is a mention of a place. And we're going to keep that information, but we don't only look into there, we also try to identify where the user was tweeting from. And in order to do that, we can identify the user location using some information from the API, or using the user declared location, or using the user biography. And so epitweetr will store both the tweet text location and the user location. And basically, we are going to store that next to the tweet. And epitweetr uses machine learning to find geographical information using a database called GeoNames, which is freely available. So GeoNames contains more than 5 million locations, including regions and cities and even villages. Okay, so once we have, so first we got the tweets, then we geolocate the tweets, and the next step is to aggregate them. And so we are going to perform 3 different aggregations for different visualizations and alert detection. The first one is what we call country count. So it's a data set you can access you can load it as our data frame that contains the topic, the day, and is going until hourly, so until the hour level. So you have So it's per topic, per country, and per hour. And you have the country of the tweet and the country of the user. And then at that, so that is like the primary key of this data frame. And then you get the number of tweets, the number of retweets, the number of tweets from known users, and the number of retweets from known users. The second aggregation level, the second aggregation data set is geolocated, which is more fine-grained than country counts in terms of location, but it's less fine-grained in terms of time. So this is not going to the hour level, but only to the date, to the particular day. But in terms of location, it goes finer into the geographical level. You can get the country, but also the geocode, which is a geocode based on the geonames database. So here, this could be a French village, for example. So in this case, those are the tweets that are, well, the user is in Belgium, but the tweet is talking about France. And this is the place that was identified. You also get latitude and longitude information, estimation for those locations. And the last one is top words. And top words is a data set that is going to show us for each day, for each topic, what are the most, and for each country, what are the most important words. So this allows us to know for each day what are the topics that are more important, and we're going to show you that into the dashboard. So the top words for each day for each country. And yeah, the column tokens is showing you actually the words that are being identified as the more frequent. Okay, so now. So we got the tweets, we made geolocalization, and then we created time series, basically. So we aggregate them, and now we need to identify if there is something out of the ordinary going on. And so in order to do that, we have to set a threshold over what epitweetr is going to generate an alert. So if the number of tweets is over a threshold for a particular day in a particular location, we are going to generate an alert. And for doing that, we use a modified version of the years algorithm. And so this formula here is the threshold calculation. And so we're using a t-student distribution, and we use this alpha, which is the false positive rate, which means the ratio of false alarms we might get. So this is the alpha you can set into in the topic spreadsheet. But something important to know is that we don't exactly count tweets per day, but for 24 hours block. So based on the last tweet we collected, we get the previous hour and we get the 24 previous hours to build a 24-hour blocks. That will be the number of tweets for the current day. And then we get a baseline, which is a n number, so a k in this case, is a k number of 24-hour blocks, the preceding k 24-hour blocks. And those counts are going to be our baseline. And but before calculating this mean here, we are going to downweight previous outliers. And for doing that, we fit also a statistical distribution, and we use the outlier alpha to identify which of those are outliers, and then we downweight them. And after downweighting, we're going to calculate this formula to calculate a threshold. And for each country, for each hour, we're going to throw a signal if the threshold is exceeded. So this is what we're seeing in here. So basically, we have a count per day, as is shown in this graph, and the green shadow is the threshold we calculated for each day. And in the report, you will see a little triangle showing that there is an alert because the count of tweets for that day exceeded the threshold, and you're supposed to receive an email if you are a subscriber, of course. So the signal detection is an ongoing process. It happens each X hour, depending on your settings. So you can set how often you want epitweetr to generate alert, but it also depends on your computer capacity and the number. If your topics are returning a lot of tweets, it may take more than the number of hours you are requesting. But if everything is fine after this number of hours you calculated, epitweetr will generate alert and will send emails. And so in those emails, you will get the date and the time slot of the signal, the locations that were detected, the number of tweets and percentage of excess of tweets, the number of tweets from trusted users, and the most frequent words. And that allow you to make a quick assessment of what is behind this alert. So, and alerts are sent via email, but are also available on the Alert tab of the Shiny app, so you can also explore them interactively. So this is a screenshot about the Alert tab. So you can see here the different tabs. This is the Alert tab, and you can see the alert that were generated on the 20th of September. You can filter by topic, by countries, and you have some information like the hour, the topic, the region that this alert was generated, because alerts are generated at country level, but also at regions. So it can be subcontinental. We have whole regions. We have also a continental and at world level. And you have a number of tweets and other information. And so then who will receive these alerts? You have the ability to define them using a spreadsheet again, which is you can find in the configuration tab, which is the subscribers, and so you can download them. And epitweetr can generate two kinds of alerts. First of all, we have real-time alerts. So each time that epitweetr process alert, each 4 hours, by example, it will detect some alerts, and as soon as detects some alerts, we'll send them if the user is subscribing to real-time alerts. And also it can be a scheduled alert if they want to have fixed times in the day, like 1 or 2 times a day. So you can download this Excel file, and this is the structure of the Excel file. So you have the name of the user, the email of the user that is going to receive the alerts. You have the topics, which you can write one or several topics. So if you write non-topics, the user will receive alerts from any topic. But if you write one or more, the alerts will be limited to those topics, and you can split them with a semicolon. If you put no filters for the topic, you can still exclude some topics. Like if you don't want to receive a particular list of excluded topics, you can use this column to receive all but those topics. Then you have also real-time topics. So remember I told you you have two kinds of alerts, real-time or scheduled. So here you can set which is the list of topics for which you are going to have real-time alerts. And here nothing means nothing, not all as topics. And then you can settle what are your regions and your real-time regions. So if you put nothing in regions, you will receive alert for any regions. But if you put some regions, you will limit the scope of the alerts to those regions. Something important to get in mind is that if you filter some regions, you will get alerts for those regions, but for any topic. So this is not an and with topics, but or. And then you can settle what are your real-time regions. And finally, in alert slots, you can set what are the hours this user want to receive his scheduled alerts. And you can set the hour in the day with semicolon. And I think we have seen all the main elements of epitweetr. And so users will get alerts. And now we have to figure out what to do and how to decide whether these signals are a public health threat of interest or not.